So let's look at an example where we have two components. Let's suppose we have benzoic acid benzoic acid in our sample, and we have naphthalene. Now, if we look at these two compounds, we should easily recognize that the benzoic acid is going to be polar because it has this carboxylic acid group, and it's a very polar group, and so it's going to be our polar component. Naphthalene is nonpolar. Okay? And so we take our mixture, we're going to spot this onto our TLC slide. Here's our origin. We're going to run that in our solvent. We're going to let the solvent move up. And what we're going to notice is we're going to have two spots that come out of that mixture, one that's going to move a great distance and one that's not going to move so much. And it turns out that the green spot, if you will, would be naphthalene because it's nonpolar and the solvent is nonpolar. Whereas the benzoic acid, being polar, is not going to travel as far. It's going to stick onto the solid support, if you will, and prefer to be with the solid support and spend less time in the solvent, so it travels less up the plate. So this is what one would see after development. You would see these two spots separated by a great distance on the plate, and they would have very different RF values. So you would calculate the distance that the green spot traveled, divide that by the distance that the solvent traveled, and that would give you the RF value for the naphthalene. And you would report that in your notebook. You would write R little f is equal to whatever value you calculate, dC over ds, and then in parentheses, you put SiOx for the silica gel, and comma, whatever the solvent was. And it's very important that you report this because it turns out that there are many different types of TLC plates. Not all of them are silica gel. It just turns out that those are the ones that we're using in this laboratory. And it also turns out that you can use a variety of different solvents. But it's very important because benzoic acid or naphthalene will have different RF values based on the solid support and the solvent. So if you change solvents, the RF value will change. If you go from a silica gel substrate to something else, say neutral alumina, it will also give you a different RF value. So it's only a constant when you have this identical condition, solvent and solid support. And so that's very important that you always make sure that you're using the same type of TLC slides as well as the same solvent when you're doing comparisons. Okay? So with these RF values in hand, one can then look up RF values for known compounds and then try to figure out what the components of a mixture are. And that's what you're going to be doing in experiment 1. You're going to be given an unknown pill, Tylenol, Aleve, Motrin, etc. You're not going to know what it is, and you're going to have to identify which pill you were given by doing TLC analysis. You'll have a series of standards, so to speak, that you'll know. This standard contains acetaminophen, another standard may contain Aleve, etc. You're going to run those standards on TLC. You'll calculate the RF values for those standards, and since you know what the components are, you'll know what those RF values are. Then you'll take your unknown, which is a pill, that you have no idea what the active ingredient is, and you will then run a TLC slide on that and calculate the RF for the component or components that it contains, and you will then identify the component or the components, and then you'll be able to identify the drug by thin layer chromatography. So not only can we separate components, but we can identify those components if we have a proper set of pure, quote-unquote, standards that we can compare RF values to. So that's the theory behind thin layer chromatography. Make sure you read the section in the laboratory manual on thin layer chromatography as well as any relevant materials in your lecture textbook. For this, you're looking at chapter 2 in the Solomon's text. That's where we talk about polar compounds, nonpolar compounds. So it'd be good to refresh your memory by looking at that chapter as well. And good luck in the lab.